So hello guys, so we're saying we are using our variable separable method to solve a differential equation. So our differential equation is dy upon dx plus 2xy equal x. Now we have the general form as dy dx should equal p of x and q of x. So our first method is to separate all the x's together and all the y's together. Now we are saying dy upon dx should equal x minus 2xy. Now from that point we are saying pull out x. So I'm saying x into 1 minus 2y. Now from that point we're saying dy upon dx. So let's separate the y's together. So we're saying 1 minus 2y. Divide this by 1 minus 2y. Similar as I multiplying this. Now from this point, this cancels this. I'm remaining with x to this other side. Now I'm saying dy upon 1 minus 2y, multiply that by dx should give me x. Now if I multiply the dx to this side and multiply the dx to this other side, I'll remain with this. So I'll remain with dy upon 1 minus 2y should equal x dx. So how will we solve this? So we are saying perform the integration of both sides. So if I take the integral of both sides, I'm saying the integral of this. So if I calculate the integral of 1 upon 1 minus 2y dy, I'll use u substitution. Okay, u substitution. So let's perform our u substitution. So we are saying let our u equal 1 minus 2y. Then our du should equal negative 2 dy. Then what's our dy alone? Dy alone equals du upon negative 2. So substitute this back inside the integral. We are saying it's the integral now of 1 upon u multiplied by du upon negative 2. If I perform this, I'll get I'll take negative a half outside, so I'll remain with the integral of 1 over u. Now what's the integral of 1 over u? It's simply the ln. It's simply ln of the absolute value of u. Then I'll multiply that by negative a half. Now from that point we are saying if we combine all these, we're saying it's negative a half multiplied by the ln of u. What's u? 1 minus 2y. Okay, plus a constant c. So this is a solution. So this is our first solution, but we want for this case add the constant of integration. Now let's integrate this other side. So the x squared dx. So we are saying integrating x dx. We are saying what will be our answer? We are saying if we integrate this, is just same as x squared upon 2. Then we add our constant of integration. So from our knowledge, you're saying a half x squared plus a constant c should equal negative a half ln of 1 minus 2y. Okay. Now rearranging this, taking this to the other side and this to the other side, we're saying negative a half ln of 1 minus 2y should equal a half x squared plus c. Now we are saying multiply through by negative 2. Okay, so if I multiply through by negative 2, these cancels this and this negative cancels that. I'll remain with ln of 1 minus 2y should give me, if I multiply this whole expression with a negative 2, so I multiply this by negative 2, I'm saying I'll remain with a negative x squared. Okay, I'll remain with negative x squared. So I'll remain with negative x squared. Okay, I remain with negative x squared minus 2c. Okay, minus 2c. Okay, but for this case we can, because this is just a constant, so it get absorbs and it remain just a constant as it is. Now we are saying it's just the same as negative x squared plus c should equal ln of 1 minus 2y. Now taking the exponential of both sides, if I take the exponential of this side and the exponential of this side and the exponential of this, and again we are saying if I take this should be equal to 1, so I'm saying 1 minus 2y should give me, if I take this, it should give me e raised to negative x squared. Then this part again get absorbed to be a constant. Okay, so it's just similar as I'm multiplying these bases, so I should be adding the powers. Okay, so if this gets to a constant, I'm saying it's just similar as I'm multiplying that with c. Okay, so let's get our y. So I'm saying taking this to this other side, I'm saying negative 2y should give me c multiplied by e raised to negative of x squared minus 1. Okay, so for me to get my y alone, my implicit, I'll get c e raised to negative x squared minus 1 upon negative of 2. Okay, so this is our answer. So if we calculate this, we are getting, remember we had our negative at some point. We are saying this is the negative. Okay, so this is negative of, yeah, so we are okay at that point. So this is our answer. So please like, share and subscribe to my channel. Thank you.